Welcome to MAT120 Statistics. I'm Dr. Archero. I'm hoping by the end of this course you'll appreciate the value of statistics and how it really permeates almost every area of our lives. I'm going to start out with some introductory material. We'll start with an example, kind of a demo. It's a nice data visualization example. What we have is data on fertility rates versus life expectancy. Fertility rates on the y-axis and life expectancy on the x-axis, the horizontal. Each bubble corresponds to a region or a country, and you can see generally it looks like the higher life expectancy seems to be correlated with the lower fertility rate for women. This is births per woman. But what's kind of interesting, there's a lot of data described here, a lot of information. The size of the bubbles corresponds to the population and so forth. Another interesting thing is that this is for the year 2015, but to get other years we can scroll or use the slider. And aside from looking pretty cool, there's some interesting features that pop out. You can see, so I'm starting at 1960 here. As I go forward in time, you can see, at least for some of the countries, the life expectancy increases, but the fertility rate goes down. So you might ask, well, is there a relationship there? You might also look to see this kind of weird action with these smaller countries out here. In 1975, this country here, Cambodia, the life expectancy dropped very low, right? And then it rebounded. So you might ask what was going on there. Similarly, this country, Rwanda, in 1992, life expectancy dropped. So you might ask that question. So a lot of statistics going on here. And part of statistics is communicating results. So a lot of times visualizations are part of that. There's a whole field of data analysis called UX, user experience. There's a whole field called data visualization. All right, so there's one example. There's another example on climate change. I'm going to leave that for class. Essentially, what we're going to do is often we'll ask a question or make a claim. Do fertility rates correlate with life expectancy, or are average temperatures rising? Well, how do you support these claims? Well, statistics is involved with gathering data, analyzing data, and then interpreting and drawing conclusions. This is a very important part of it. And then also very important, communicating results. So it's the same with every type of statistical process, polls, surveys, etc. Data. What do we mean by data? Data is just collections of observations. Could be anything, just about anything. And statistics is the science of gathering, organizing, summarizing, presenting, analyzing, and ultimately drawing conclusions or making inferences. Interesting little factoid here. Some websites that deal with or that have great examples of either data visualization or statistics. Data journalism is an interesting field which has only recently come about. You know, now that data is infused everywhere. This is a website called 538.com, and it's a news site, but literally every story is infused with data analysis or or statistics. You can look at this story here on the Patriots' path to the Super Bowl, and just clicking at random, you generally don't have to look too far down to see some data analysis and statistics. Sports are a really rich source of statistics. And of course, they've got the running Trump approval-disapproval poll, which is found by an average of several polls. They take a whole bunch of polls, average them together, and that gives you the solid line. And you can see how it tracks over time. So data journalism, field that didn't exist a few years ago. Here's some places where data scientists and statisticians are employed. All the technology companies use statistics and data analysis extensively. Certainly in healthcare and medicine with clinical trials and drug testing. Professional sports teams all have analytics departments now. Used to be a novelty. Business and finance, social and natural sciences, of course. All the sciences need statistics. So the way we proceed, we typically have some population we want to gain information or knowledge about, and what we do is take a subset of that population, which is called a sample, and do statistical analysis on that sample. So what we'd like to do is make inferences or draw conclusions about a population based on the sample. Now, in some rare cases, we're actually able to take data from every member of the population. That is called a census, but usually we can't do that. If it's a political poll, we can only sample several of the voters, or a small group of voters rather than everyone in the country. Here's an example. I'd like to estimate the percentage of colleges in the U.S. which have a ski club. So we'll take the schools in Maine as our sample. Okay, so the population is all U.S. colleges. The sample is Maine colleges. Sample bias is what happens when there's some systematic way in selecting the sample that tends to skew the results. So we would like our sample to represent the population, and we want it to look like the population. And if we're using some method of selection that tends to make it not look like the population, that's called bias. Ski club example, why might that sample be biased? I want you to think about that. So sampling methods, the validity of statistical results depends on the methods. You could spend an entire course talking about that. If your sampling is bad, then you're not going to have valid results. So we'll talk about three types of sampling. One is the simple random sample, and this simply means that all the samples of a given size are equally likely to be selected. The idea is to reduce the likelihood of bias. Typically, one would use a computer to generate random numbers and use that as a means to make your random sample. So other types of sampling methods, voluntary response, is just like what it sounds like. And some examples are internet polls and call-in polls and that type. These tend to be biased because people who feel very strongly about an issue tend to call in one way or the other. Also, if it's a radio program, for example, then the listeners might skew one way or another politically, and that will skew the results. Another type of sampling that sounds like what it is, you might sample or poll all the students in your dorm or on your floor. Okay, so especially in the case of clinical trials and drug tests and things like that, not always possible to do random selection of individuals. So researchers try to control for bias in other ways. Okay, but typically with clinical trials, you need more than one study or trial in order to confirm results. You know, often get contradictory results, so need to be supported by numerous studies. There are a lot of pitfalls to look out for when reading about statistical results. I'll direct you to the text for these, but we'll look at one or two examples. This example here is right from our text. This is on page 2. So if you look at this graph of printed versus electronic text and student preferences, it looks like way more students prefer printed version. But if you notice, the horizontal axis, or the vertical axis I should say, starts at 30% rather than 0, which would be down here. So really it's about twice as many that prefer the printed, and not like 4 or 5 times. So that's kind of that's a misuse. There are even books written online with statistics. Here's an example of a loaded question. So you can consider these two questions which ask the same thing but in very different ways, so would tend to elicit certain types of responses.